Okay, so it's time we start with today's session. That is day two for Data Science Master Bootcamp. I hope you had a wonderful day yesterday with Mr. Manikanta. I think he tried explaining you the different aspects of the framework for analyzing data, and also share some of his experience while he was working on this project. Well, I'm going to continue with the same project today, and quickly to talk about myself. My name is Omkar Raikar. I'm global head for analytics and research for Bayesian Analytics. I take care of end-to-end data science, lifecycle management, as well as helping companies to adopt the data culture. Moreover, I'm also a co-founder with Business Toy Private Limited. And in today's session, I'm going to help you to continue the topic which we had left, kind of incomplete, and we are going to analyze the same data which we were trying to, in fact, yes, understand yesterday. So, with respect to the framework, I believe, I think I can ask you some questions based on the yesterday's session. So, if you can just tell me, um, what was what was the key insights, or what was the problems, what was the problem and the analysis yesterday? If you can just throw me some quick questions, or some quick insights based on what did you study yesterday? Just 2 points from everybody quickly. So what was the problem statement and analysis? Okay. Okay, there are some people saying that okay, they wanted to understand, what can be done with the data. The data was given to you. All right. Okay, so there are some people saying, like how to use data to improve businesses. Okay, framework for data science. Okay, to classify the data and get information. Okay, I believe there are some people, like a lot of people that are also joined new. They hadn't, understood, and they didn't attend the yesterday's session. So don't worry, guys. Even I'll help you guys to, connect with what session we are doing today. I can see there are 10 more people as compared to yesterday who have joined new. So the people who have joined new, don't worry. I'll be telling you each and every aspects of what we are going to do. All right. So okay, so I have quite a lot of people answering me, the same thing. So we will get the PPT? Yes, some people are asking me if we will get the PPT. I'll be sharing the video link of this 2 days of training session on YouTube. So in our on our YouTube channel, you will be getting the link for your further, like reference or anything. So I we may not be able to send the PPT, but then definitely we will be sharing the link so that you can, analyze this again. And all that you need is the data. The data file is there with you. And the people who are not able to download data, don't worry. I'll be again mailing this data along with I'll be giving the link of the YouTube, not the YouTube, sorry, the Google Drive file in the YouTube, and then you can download it from the YouTube. So even if you are attending this training session from phone, don't worry about it. We will be giving you the link to the file as well as the YouTube video so that you can practice this in future if you wish to. All right. So I think it's time for me to just quickly recall the framework for data science. So the first and the foremost thing is that understanding the problem statement, right? So I think in yesterday's session also a lot of time was consumed in understanding what exactly is the problem statement. See, guys, there is always a this big misconception in people's mind that a data scientist is a very good programmer, and they focus more on the programming aspects of a person knowing like a particular tool or a language. Okay, it's not all about knowing a tool or a language. Okay, so the major part of the entire data science or data science profile is understanding what exactly we are solving. Okay, what is the problem under analysis? Okay, we call it as a problem statement, right? So without a problem, there is no need for any innovative solution. There should be some problem that the company is facing. There should be some problem that the business is facing, and since the problem exists, we exist, right? We as a data scientist exist. So uh, the first and the foremost step is, like you going into the roots of the problem, understanding the problem from scratch, doing a research around what are the different factors impacting this particular problem. Maybe, I think this phase is a very, very crucial phase, because we need to first also understand here, is this a problem that, which cannot be, cannot be solved by normal tools? Okay. Does this particular problem really require a data science? Maybe this is a first question that you need to ask after you understood the problem statement very well. So there could be some, very, very simple, task where you do not need data science, or the cost of implementation of the data science strategies could be very high in some of the cases, right? So in such cases, you need to understand, why are we exactly trying to solve this particular problem using data science? Okay. And that is what you need to answer. Now I would like to ask you I ask you some questions. Okay, some questions based on maybe uh, the this phase. Like for example, how do you understand whether a problem can be solved using data science or not? Is there any perspective that you have? Can someone tell me what kind of a problem should be data science based problem, and what kind of a problem should be, the problems where you really need humans? If you can message me in the Q&A, what kind of a problems really require data science? If you can just think of, I'll be definitely helping you to understand, but I want to know your perspective. Having a lot of features in the records. Okay, see, I'll tell you, like having a lot of features in the records comes secondary. What data you're collecting comes secondary. The first thing is understanding what exactly is the problem. I'll tell you various type of problem. Okay. Okay, there are some people saying predictive issues. Okay, very good. If you have data, okay, if we have don't have a data, we can have some strategies for collecting such data. Some people are saying market research related problems. Mm, okay, one very good topic for discussion. Maybe we can take it up as a topic for future webinars. What is the difference between a market research and data science? Definitely, I think, this is one of the key issues where people are a lot confused about what is the difference between a market research and data science, right? Okay, some people are saying the problems which are recurring or a process driven. Yes, the process driven problems can definitely be a data science problems. um, okay, the problems which do not involve research. Okay, yes. See, there are two aspects here. There are two important aspects that we need to understand. um, well, the main thing that you need to understand is, when do humans fails and when do machine fail? Okay, machines cannot do research. So any kind of a problems requiring intelligence. Okay, any kind of a problems requiring intelligence is where you need, a human. And any kind of a problems which are process. Okay, they are, like followed through a process. Like for example, I'll tell you, let's say there is a call center, and why we have this particular call center is to solve some real issues relating to the see, let's say for example, there is a company which is into telecom. So there are some of the common issues are network failure. Some people SIM card is not getting detected. Some people are not able to, pay the bill. Okay, so there are some specific categories of problems, and there are some, there are some SOPs means systematic operating procedures, right? So these operating procedures are given to the people who are in the tech support, or in the like in the customer support, right? And these problems are very common. So whenever a person gets a call, the person in the tech support will straight away address that particular issue, and now it becomes a process. Okay, they have basically made a process. So any kind of such process can be automated. Okay, so any any kind of a problem which can be formulated in the form of a process, okay, can be considered as a data science problem, and majorly your data science can solve such problems. All right, so there are some problems where you need to have some kind of a mindset where a person need to determine how much will be the sales in future, or whether a particular person will be purchasing a particular insurance policy or not. Okay, how much could be the salary that could be given to a particular person. Okay, so there are multiple problems under the business domain. There are also some problems which are coming under something called as a technical domain. Okay, so first of all, we need to have a thorough understanding about what kind of problem is what we are trying to solve, right? The second step that comes under under the framework for data science is understanding the data. So after you understood the problem, just check if you have relevant data that can help us solve that particular problem. Okay, the data will be always available in abundance today. Like, you must be hearing a lot of YouTube ads, you must be seeing a lot of Facebook ads talking about you know a very common agenda, saying data is a new oil. I definitely agree that yes, data is a new oil, and there is so much of a data that the companies are sitting up with, and there are many companies who even don't know how to use this data, right? So definitely this leads to a big problem, thinking, okay, how this data can be utilized and what kind of problem statements can be solved, right? So the next thing that comes under the framework is the classification of data. Can someone help me understand how is the data classified? I think yesterday you must have had a very good discussion around how what is the data classification. Can someone just message me in the Q&A? How is the data classified quickly? I'll wait for your answer. So what are the first two broader categories? Continuous data, categorical data. Very good. Okay, there are some people saying, qualitative data, categorical and continuous. Some people are saying, okay, the major two categories and major two classification are categorical data and continuous data. And I think you can tell me what is categorical data. So what is a categorical data? Quickly, can someone tell me? Okay, categorical data is having a finite possibilities. So it is, yes, many people are saying yes, it is a finite possibilities. And then they are also saying that there are two classes for it. One is ordinal and one is nominal. Can someone quickly tell me example of a nominal data? What is a nominal data? Okay, gender is a nominal data. Very good. Anybody else? Anything else? Any other example? Okay, blood group. Okay, wonderful, wonderful. So I have some good examples for the nominal data and ordinal data. I know that it's a data which is having a hierarchy. So yeah, so when it is a hierarchical data, like for example the size of the t-shirt, right? Or we have the scale which where we say disagree, agree, whatever. We also have a ordinal data on the ratings for movies. Okay, some person is saying a pin code for nominal data. That's absolutely correct. Pin code is a nominal data, but then like it's a high cardinal data. Okay, so cardinal data means that when there are many categories to be handled, and then that we call that issue as a problem of a high cardinality, right? So there are multiple aspects of data classification, where we have categorical data, and under categorical data we have nominal data and the ordinal data, which is a hierarchical data. The other classification is, I think, the numerical data and non-numerical data. When numerical data for takes into consideration all data points where which can be where we can use mathematics, right? When we can sum it, where we can aggregate it, right? So those are the numerical data. Non-numerical data are majorly used as identifiers, like for example your customer IDs. Okay, you have your roll numbers in the college, you have your phone numbers. Even a phone number is a non-numerical data, though it is a number, but it's an identifier. I cannot add two phone numbers, right? That's wrong thing to do, right? So now, since we have also understood the classification of data, the next thing that comes into the picture is something called analysis of categorical variables, right? And I think until here is what you have done yesterday, where like we tried understanding the data, where we also understood how to identify the days of the week, and so many things. I'll just go through that once again in the Excel sheet. But before that, let us lay down the complete framework, and let us try to understand what all things that we're going to learn today, right? So the next thing that comes after analysis of categorical data is analysis of continuous variables. Okay, so continuous variables are majorly numerical variables, where we use something called descriptive statistics, which I'll be teaching you today. The next thing that comes under this is relationship study. So where we try to relate one variable with another variable and try to understand what is the impact, okay, or what is the change that is happening to other variable with respect to change in one variable, right? Like for example, if the sales of ACs increase, okay, and why it could increase is because there is a the increasing temperature outside. So if the temperature increase, the sales of ACs increase. If the temperature increase, the sales of ice creams increase. So we can try to understand if there is any relationship. Sometimes there may be some strange relationships existing in the data, so which we need to examine, then and then like basically try to do more research on why such relationship even exists, right? The next thing that we do is something called predictive modeling, and that is how we are going to today going to stop with our webinar, right? So these are the different things that we're going to do. If you have if you can take a small screenshot of this so that we can refer to this again and again. So take a quick screenshot. I'll just tell you this steps once again. The step number 1 is understanding the problem statement. The step number 2 is understanding the data, okay, and trying to understand whether this data can really help us solve this particular problem. Step number 3 is, once we have finalized on the data that we're going to use, we need to understand and classify the data under categorical data, continuous data, and its subclassification. The next thing, that is step number 4, is analysis of categorical variables first, because categorical variables are relatively easier to understand, and because there is no statistics involved. Okay, then comes in something called continuous variable. Continuous variables are the variables which are numerical, so we use something called descriptive statistics. So here is where your descriptive statistics part will come into play, right? The next thing is relationship study, where we try to understand if there is any relationship between the two variables, and then we use predictive modeling, and then this is how we are going to stop with or and or conclude with our webinar today, right? So let me just exit my screen and move on to the Excel file that I think we had shared with you yesterday. So let me just stop sharing my screen. Give me a moment. Okay, let me just share that screen with you. Give me a moment. Okay, so we have this data with me right now. So which the data which we had tried understanding yesterday. And then I think the first thing that you had done was identification of a type of data that is existing in this entire the type of data which is given in this particular data set. So yesterday I think we also classified. I won't take much time in again revising the different aspects of classification, but quickly to tell you what are these different types of classification, I'll just quickly make a note here. So I have this different features. I think this was explained to you yesterday, that the columns are also referred to as the features, right? And I'll have these features over here, and I'll quickly name them under different categories. So the feature number 1, that is customer, can be classified as a non-numeric variable. The day is a ordinal categorical variable. Okay, the browser is nominal categorical variable. Okay, clicks are numerical. Okay, and then the pages are maybe we can have a pages as categorical, no, not categorical, sorry, numerical. And then time is also numerical, and we have amount also numerical, right? So this is how we have to classify our data the moment we get the data, because this particular framework will be really helpful for you when you are new in data science domain, where you are like new to data analysis. Because most of the time I've seen people getting confused at this stage of what to do with the data. Okay, they don't understand. The moment they get the data, they don't understand what to do with the data, right? So this is the most important aspect of it. So yeah, so this is my step number 1. Okay, the step number 2 is, I think you did yesterday. You tried understanding this data one by one. Okay, like as in you tried understanding the categorical data first. So I think I'll just make a step here saying analysis of categorical data. Okay, where you tried creating some kind of a pivot table where I click anywhere within the data. Okay, and then I click on insert. Okay, basically I want to know what is the frequency of Monday, what is the frequency of Tuesday, what is the frequency of Wednesday, and so on and so forth, right? So I click on pivot table, and then I click on existing worksheet, and I click somewhere here so that I have the table here itself. I think yesterday you had prepared a table in a new sheet, but today I'm not doing it in a new sheet because it will take a lot of time for me to complete that. So I'm having it here. So this is the pivot table. And to be precise, I'll just tell you how we can have a pivot table appear, giving me the data that I want. So I have clicked on the day, dragged it into the rows. So there are four things that are supposed to be used here. Something called filters, columns, rows, and the values. So right now I want the data, the days, to be coming in the form of a rows. So all the days are coming in the form of rows, right? And the same days, if I drag it into the values, it will tell me which days or which days we are having, what is the frequency of different purchases happening on different days. By looking at this, we also understood that most of the people are purchasing on Friday. The second highest is on Monday, and then I think you decided to give offers or discounts on Wednesday based on something called median based trend balancing. So which I'm sure that you had studied and implemented yesterday. And I think also Mr. Manikanta have told you how we can label this up. Okay, how we can label this up as a particular color. Like for example, I think he had used a red color for identification of the type of like which day you are giving discount. And I think you can give a storytelling title for this graph, and the storytelling title could be offer discounts on Wednesday. All right. Okay, so this is what you did yesterday. I'm not going into the details of it, just because there were some new friends of mine who had joined today in today's session. They might not, they might feel disconnected. I thought just to do this once again. So the same way, I think the one more exercise that was told to you was you had to tell which day people purchase, I mean to say which browser people purchase the most. And likewise, you can do a lot of analysis. There may be some analysis that you can do where you can understand which day people click more number of times, okay, or which day people view more number of pages, or which day people spend more time, or which day people spend more amount. Okay, this can also be done. Okay, but the first thing that you should do is something called simple frequency distribution. This is called frequency distribution. So these words look a bit heavy, but then they are not so complicated. Okay, so frequency distribution is a simple count of different categories. Okay, the simple count of different categories. Like for example, in this data that we have, okay, Sunday is recurring or occurring or appearing 22 times, right? Then the Monday is appearing 37 times, or the Friday is appearing 42 times. Okay, so we can understand a simple trend in the data here that most of the people are purchasing on Friday, maybe because Saturday and Sunday is the holiday. Okay, and I believe this the case was with respect to one company which was recently launching its phone in India, and this was back in 2014, where the smartphone present penetration wasn't so great. So that's the reason people are not having access to their desktops to order the phone. All right, and then we are having some some many people purchasing on Friday, and the people who didn't purchase on Friday, they had a rollover effect, and they purchased it on Monday. And we saw every time that the midweek used to have experienced the lowest sale. So we thought, okay, we will give some kind of an offer, and then if this, like this, due to the offer, people start purchasing on this day, then the overall sales will look balanced, right? I'm not doing it for the days. Again, I'll leave it to you. And if you can solve this, if you can tell me, you can explore this entire data and mail it to me back, I'll definitely help you to learn data science even better, right, in future. So if you can, after I send the data to you, if you can work like telling me which day people purchase the most, which day people spend the highest amount, or if you can tell me also which day premium customers purchase. Okay, that is another a next level of question that we can ask to this data. Or which browser the premium customers use, or how do we identify premium customers first of all. Okay, so such things, such questions can be asked, can be basically answered by using this type of data, right? So now I would like to have the next step explained to you. That is step number 3, and that step number 3 is analysis of maybe the continuous data. Okay, the analysis of continuous data, we normally call it as descriptive statistics. Okay, this is very, very important aspect of statistic. And when you analyze any data, the power, okay, that can be given to any kind of a machine learning models is where is driven by this important step, that is analysis of categorical data, continuous data. Okay, and it is called as the descriptive statistics. Now I'll tell you the different components of descriptive statistics. I won't be able to go into real depth of descriptive statistics, but I'll tell you what is the main purpose of it, and how we can calculate descriptive statistics, and few aspects of interpretations which are most useful for our analysis in today's case, right? So when I say descriptive statistics is used, okay, is used to describe the data. Okay, is used to describe the data. Okay, so this is the most important. Like for example, I want to describe a human. Okay, I say how tall he is, whether he is a fat or whether he is thin, or what are the characteristics of that particular person. So in order to define or describe the data, even I need some kind of a touch points. I need some kind of characteristics with using which I can tell my people that yes, see, this data looks like this, so I can analyze it this way, right? So this is what the purpose of descriptive statistics is. And in descriptive statistics, we calculate the following things. One is something called minimum. Okay, I'll write it complete so that you're not getting confused. Minimum. We also calculate something called quartile 1. We calculate something called mean. We calculate something called median. We calculate something called quartile 3. Okay, we calculate something called maximum. Okay, the other aspects I may not be able to explain because of the time limitation. That is something called standard deviation. There is something called variance. Okay, then there is something called kurtosis, and there is something called skewness. Now if someone says like, if descriptive statistics, then these are the different measurable parameters that you can talk about, okay, in order to describe the data, right? So now, since I said I'll tell you how to calculate these things, the calculation part I'll explain you first, and then let us quickly jump into the analysis part. Okay, so let me just do the quick calculation. So in calculation, basically I'll be doing descriptive statistics for continuous data. Okay, so continuous data that I have is, or numerical data that I have is clicks, pages, time, and amount, right? So basically I want to know here, if you want to talk to this data, then I want to know what are the minimum number of clicks happening, what are the maximum number of clicks happening, what are the average number of clicks happening, right? I also want to know various other aspects which I may or may not use based on the flow of our today's session. So the first thing that I'll do is I'll calculate the minimum. So in Excel, we can calculate minimum as equal to min tab, and then I select this data. Okay. Now, in order to select the data, yesterday, I think Mr. Manikanta must have also told you some shortcuts where control can be used as a jump key, and shift can be used as the selection key. So I use control shift and then down arrow key, which will help me select the entire data. Okay, and then I hit enter. So this will give me the minimum number of clicks happening on the website, right? And then we have the maximum number of clicks, where we have, is equal to max. So I want to calculate the maximum number of clicks which are happening on the website. So I select this and then I get, 8 to 46, right? 8 is the minimum number of clicks happening on the website, and 46 are the maximum number of clicks happening on the website, minimum and the maximum, right? So why do we need to understand number of clicks, or what number of clicks as a feature tells us? Okay, so number of clicks basically tell me how much has been the research that have happened while purchasing this particular product, right? How much was the research that was done? Was that customer a very quick decision maker, where he didn't think much, he just explored and then understood few basic things about the product and then he purchased? Or was this customer a highly research oriented customer who explored everything in the website and then purchased, right? So I this will clicks will give me some idea about what kind of customer behavior was exhibited, or what kind of a customer behavior we are experiencing. Are we having customer who are quick decision makers? Are we having customers who are very very decisive with respect to their purchase? Are they doing a lot of research? So we can have such kind of a behavioral study done when we have a data for number of clicks. Okay, now number of pages can help us understand how many comparisons were done with respect to this particular product, because normally when we compare products, and if there is no product comparison feature available in your website, right, so we tend to open multiple tabs. Okay, now when I say pages, these pages are number of tabs which are opened, or number of times you have seen different pages with respect to this particular website. Okay, so pages will, again, it's kind of again the parameter which will help me understand how much the research has been done. But then this is a accurate parameter which can help me understand how many products were compared with this particular product, right? And then we have the time spent will also give me was the product, was the particular customer again taking a lot of time to decide, or these all three, if you have to classify them one in all, then we can say that these are the behavioral aspects, right? Now with respect to the amount, okay, the amount can help me understand understand whether a particular customer is a a premium customer. Okay, is he a a customer who is a below average customer, or average customer? Okay, and I'll tell you there are some strategies by which we can identify them, right? Now we have minimum number of clicks, we have maximum number of clicks. Now I want to know the mean of the number of clicks which are happening. Okay, so the mean can be calculated as equal to, mean is nothing but average. Okay, so I say equal to average, and then I select this data. Okay, so with respect to this, I'll understand that the mean of the total number of clicks which is happening is 24, right? And then I have median. Median is equal to median. The same way we calculated mean. Mean is the average, and for the median, it's equal to median. And then I select this entire data. I'll get the median. Guys, if you are trying to do this along with me, don't do it as of now. I recommend that you can do it immediately after my session. And then if you have any questions, again, you can mail me anytime. Don't worry about that. I'll be helping you without a question. Okay, so you can have a look at this, and also you'll be having this video of recorded session, so that you can refer to this particular session and practice on your own. Okay, it's a very good step that you can you look at the video and then you try to do it on your own, and then the understanding will be much more deeper. We'll also get more time to discuss, more time to analyze this particular case, right? So as I was rightly saying, we have now the minimum number of clicks happening on the website. So there is a customer who is visiting my website, clicking 8 number of times and purchasing a particular product, and there are some customers who are coming on the website, clicking 46 number of times and then purchasing a particular product. Okay, now on an average, any customer who comes on the website, he will be clicking somewhere around 24 or 22 number of times and then purchasing a product. Now I'll just calculate quartile one, and I'll just give you a very fair idea about what the quartile is. But then I would love to go to the detail, but then due to time constraints, I may not be able to for today's session, right? So I say equal to quartile, See, there is a simple quartile function, present in Excel. So, you say quartile, and then you click on the clicks, control shift down, you select this particular data. Now if you see here, this is my formula bar, and in this formula bar I need to select which quartile you want. Okay, which quartile you want, meaning, like I want the first quartile to be there right now. Okay, first quartile represent 25 percentile of the data. I'm not going into the details of what is that 25 percentile right now, but then I'll help you understand how this can be applied and learned. Okay, so now we have quartile 3. There is no quartile 2. Okay, and the reason there is no quartile 2 is because quartile 2 is nothing but the median. Okay, so now we have quartile 3. I'll quickly tell you what we have done. Okay, minimum is 0th percentile of the data. When I say percentile, don't get confused between percentage and percentile. Okay, percentile is the relative measure of performance. Okay, when I say relative measure, the person having the maximum score, okay, or the clicks which are maximum are 100 percentile. Okay, I'm sure that you'll be aware about this. And then we have entire data into two parts. Okay, below median, above median. Below median are the times when person has clicked, 50% of the time where person has clicked between 0 to 22 number of times, and the rest of the data falls between 22 to 46 number of times. Okay, and now if you have to subdivide this median and then go to the half of 0 to median, then we calculate something called quartile 1. Okay, so this is 25 percentile and this is 75 percentile. Okay, so if you didn't understand this again, I'll just tell you quickly. So we have basically divided our data into four parts. Okay, like for example, if I organize this data from minimum to maximum, then minimum will be 8. Okay, maximum will be 46. 25th rank of someone in the list is 18. 50th rank, meaning the half, okay, is 22. 75th rank is 29, and then 46. Then quickly I can say here, the people who are between, people who click between 0 to or 88 to quartile 1, that is 18, are the people who are quick decision makers. These are the people who take a lot of time to decide, and this is the average behavior of people who are coming on the website. Okay, so as I just said, this is how we can do something called customer segmentation, okay, or behavioral segmentation, okay, using quartile as a simple measure. Okay, we can use simple measure as a quartile, and we can say this is how we can classify our people. We can say these are the people who are quick decision makers, that is between quartile 0 to quartile 1, okay, or minimum to quartile 1. Okay, the people who are between quartile 1 and quartile 3, this is the 50% of that central part of the data. Okay, so these are the people who are, like, this is the average behavior which was observed. Okay, so this is the range that can be given. So most of the people who visit our website, they click between 18 to 29 number of times. All right, and the people who are between quartile 3 to maximum, these are the people who are, the premium, or we can say them as the people who are not the premium. In fact, they are the people who are taking a lot of time to decide before the purchase, right? Now, simply to calculate standard deviation, I won't be using standard deviation in my today's session. Okay, so maybe in some future session I may be going to I may take up the topic as descriptive statistics itself, and I may go into the depth of it. So you can stay tuned on our website to check what upcoming the training sessions which are coming up. So yeah, I'll just calculate standard deviation. So the standard deviation of the data is 8.6, and the variance, okay, these are very simple concepts. In fact, you may even Google and understand them, but then the interpretation part is what you may not find on the Google. So like, let's just calculate it for now. This is how we calculate the standard deviation and the variance. I also calculate the kurtosis, also equal to cut, and then I select this. So we have kurtosis and then equal to skew. Okay, and then we can select this particular data. So if you see, the calculation is quite simple. Okay, the calculation is even more simple in the other tools like Python or R, or any statistical analysis software. Okay, so this calculation, trust me, is even more simpler there. So these tools, like, if you may think about Python is something great, no, Python is even making your job easier. Okay, so even R is making your job easier. Or if you have something called SPSS is not nowadays not much used, but then still, like, these are the tools which are there to make your life easier. Okay, so the main thing is, are you able to analyze this data? Okay, are you able to get some sense out of this data is the most important thing that is expected out of you as a data scientist, right? So this is a bigger challenge, and I just give you a small example how we can use or how we can perform something called segmentation of the customers based on simple quartiles as a parameters. Now I can just select this. Okay, go to the corner, just see how I'm replicating this entire thing for the rest of the features. One way is I can sit and calculate each and everything manually, but then I really don't want to do anything manually. So what I can do is I can select this data. Okay, not from the clicks, only the numerical part where we have used some formulas, right? Then I can go to the corner of this. Okay, click there, and then this drag this horizontally, right? This hash is coming because the number is a bit big, so we can reduce the number of decimal places, and then yeah, I have it. Okay, so this is how we calculate the descriptive statistics. Okay, quickly, to have like some kind of a segmentation parameters, just the way we calculated the behavior based on the clicks, I can also calculate, I can also analyze the behavior based on the amount. Okay, so when I say based on the amount, I can say that these are the people who are not so premium people. They're purchasing the below average products which are sold by my company, and these are the products which are there, like between 8,417 to 15,851. If someone is buying a product in this range, then he is my premium customer. I can say that he is a premium customer. And guys, this like this ranking has basically happened based on the simple percentile measures. Okay, these are the percentile measures, and in the percentile measures, the person with the highest amount, okay, highest amount spent is the 100 percentile. So we can say that, like, these are the people who are my premium customers, these are the people who are my below average customers, and the people in between are my like average customers. Okay, these people between quartile 1 and quartile 3. So if you are buying a product worth a range between 4,773 to 8,417. Okay, these are the people who are average customers. These are the products which are like average build, right? So this is how we can like analyze the descriptive data. Similarly, we have something called standard deviation, which talks about the stability of the mean, which talks about like how much is the volatility present in the data. I may not be able to tell you this right now. Okay, kurtosis talks about you know the total amount of data centered towards the like in the mean, centered towards the central tendency, that is the mean or the median. So like there are some things which are very important, especially skewness and kurtosis play a very important role. But then, like, right now, if I start it will take me at least an hour to tell you only these two things, right? There are my students who are already also attending along with you guys, so I can, and they know exactly the way we go through explanation of this concept. It takes a lot of time, right? But then what you can see is the most important takeaway from this entire discussion that we just had in step number 3 is descriptive statistics is a very, very important aspect. We cannot skip it, and it gives us a lot of insights. Okay, it gives us a lot of insights. Okay, I would like to take a small pause and take up your questions. Okay, like to take a small pause. If you can just throw some quick questions in the chat box, it will be good, so that like I'm not hurrying up, and then you're understanding what I'm trying to say. If you have some quick questions, just post it in the Q&A, and let me just answer those quick questions. Anyone? Okay, I've started getting questions. Okay, thank you. Okay, I have some more. Okay, some people are saying, okay, like how can we understand descriptive statistics in detail? Guys, like definitely in future, I may do some more webinars for you to help you understand this descriptive statistics in more detail. But then, like because of the time limitation, I have to also cover up the entire cycle and I give you the overall explanation about the entire life cycle of a data science and data science the framework of data analysis in a very short and crisp manner. So maybe not right now. I'll definitely help you. But if you can do it in Excel, then why R? Very good question. Okay. The question is, if you can do it in Excel, then why R? I know it's stupid to ask, but still, no, it's not stupid question. I'll tell you, like, why R is because, see, Excel has this limitation with respect to the size of the data. Okay, Excel also has limitations with respect to capabilities. Okay, so like the basic analysis of statistics, even to an extent that we can help businesses to take some decisions, we can do that. Okay, but then if you have 1 trillion rows of the data? Okay, so Excel can handle maximum number of rows which are 5 lakh. Even it cannot handle in fact 5 lakh. It depends on the size of the RAM that you have, right? So like if you have huge data, and definitely in companies you have huge data, you have ERPs which are storing data right from inception of the company. So like in such cases Excel becomes helpless. Your Excel, the best friend, cannot help you. And trust me guys, even now today many of the top executives, they use Excel. So even if you know R, if you know Tableau, the Power BI, or Python, many things, but then when you go and speak to them, you'll have to communicate your results to them in by using Excel only, because they don't understand Python, they don't understand Tableau. Okay, so they will ask you like, can you show me this quick calculations using Excel? So as a data scientist, I'll tell you guys, for me, Excel has played a very, very important role in my career until now. Okay. So even now today, when I'm like explaining it to some senior person, I first understand his level of expertise, his level of understanding, his level of skills. And based on that, I introduce him the analysis that I want to present. Okay. So Excel is very important, but at the same time, Excel has limitations. I hope I have answered your question. All right, I have some more questions. Yes, I'll be explaining you the aspects of correlation. Just hold on for a couple of minutes. I'll come up there. All right, I have some more questions relating to how the descriptive statistics can be visualized. I really wanted to, but then just you can just Google about something called histogram, and there is also something called as box plot. Okay, something called KDE plots. Okay, guys, these names are just big. These are not so complicated. So there are some ready libraries which we can use, and we can plot these plots in the Python, or even in Excel. We can do quite a lot of it. So maybe sometime in future, definitely will help you to understand these things in more detail. All right, I think it's time for me to proceed. I don't want to hold you back for a long today. Give me a moment. I'll just share my screen. Meanwhile, if you have any questions, you can ask me. I'm having my trouble in sharing the screen. Just give me a moment. All right, I'll just share my screen with you. Yes, I have it here. So I think we have now understood the analysis of continuous data. I'm interested in descriptive statistics. I really appreciate if you go through this, if you can solve this and apply your own mind and mail it to me back. I'll share my email ID with you. I think you must be already having my mail ID because you have got the mail for the registration of the webinar. You can send me anything that you want, any question that you have, you can ask me over the mail itself, right? So next is step number 4. Okay, step number 4 is analysis of relationships. analysis of relationships. So in today's session, I'll be focusing on analysis of continuous variables relationship. Like for example, what if I want to really test if the clicks which are made on the website, the amount also is impacted based on the clicks that you made. Okay. What if I want to understand if you click more number of times, then you also spend more time, more time. Okay. If you say, for example, if you do 13 clicks, is there a relationship between the clicks that person makes on the website and the time? I may have to explore that. Okay, is there any relation between the time that is spent on the website and the amount spent on the website? Maybe, I don't know. So I'll have to check the relationship, and if I want to study the relationship between the two variables, okay, I use a very important statistical tool called correlation. Let me just make a note of correlation here. So correlation just help me understand the relationship between two variables. Okay, only two variables. You cannot have more than two variables. And anyways, any which ways you will analyze the relationship, maybe two at a time, right? So the if you want to understand the clicks are related to the amount, because if the clicks are related to the amount, the very important aspect that comes in our mind is, maybe, okay, if I increase the number of clicks, the amount spent will also increase. Okay, if there is any kind of a positive correlation between them. Now let me just tell you what are these different types of correlation. The different types of correlation are positive correlation, we have something called negative correlation, and there is something called no or zero correlation. Okay, no or zero correlation. So there are three types of correlation. So very simple, like if you must have studied in A standard something called proportionality. So in proportionality, we also always used to say that directly proportional, we have inversely proportional, we have no relation. So positive correlation, you can layman term, you can call it as directly or directly proportional. We have inversely proportional as negative. And if there is no relation, okay, there is no proportion that can be explained between the two, then that these are non-proportional or non-correlated data. Okay, so positively correlated, negatively correlated, non-correlated, right? So a positive correlation example could be, you must have seen, like I'm just taking some random example. This example I use for to tell you correlation as a concept in such a way that you will never forget it. Okay, so you must have seen this two people in your office or in your college or anywhere. They'll be always together. They have their lunch together. They come to office together. They go from office together. They have some good time together. So these two people always, like to spend time together. They move together, right? So these are called positively correlated people. All right, so we have something called negative correlation, where there are two people in your office where you don't get along them, right? You hate them, you don't like to talk to them. So these are the people who are negatively correlated, right? And non-correlated, you must have seen those two people in your office where or you must have yourself experienced it, where there are like 80 people on the floor in my office, okay, or in the college. I speak to 10 of them or 15 of them, but there are some people whom I never interact with, but then only during their webinars we go to like just go and eat the cake that they share with us and listen to the speech that they want to give it to us. So you can think of this as a concept of correlation. The correlation, the good friends are positively correlated. The bad friends, not, I won't call it as the bad friends, they are not getting along, they fight with each other a lot. So these are the people who are negatively correlated, and there are people who are non-correlated. They don't share good vibes. Maybe like they never spoke to each other and didn't get a chance. So these are the people who are non-correlated. All right. So the same way that in data, the features can have some relationship. Okay, like clicks, like amount, like pages, and this data, this information can be crucial in understanding and devising some strategies. Okay. Now, when I say I want to devise strategies, okay, if I find if there is any relationship between the clicks and the amount, that is hinting me that I should improve my user interactivity on the website. Okay, I should change my UI. Now you will say that I don't know anything about the UI research, I'm not the UI engineer. But you are giving information to your UI engineer that was, see, people are not clicking on the website, they're not interacting well with the website, and if you happen to increase the clicks, then definitely the amount spent on the website will be more. That's the very big information that you're giving it to him. And also I'll tell you, there is a range in which this correlation will throw you a number. Okay, that is the correlation that we are studying is something called as a Pearson's correlation. And Pearson's correlation will always give you a number between +1 for positive, -1 for negative, and 0 if there is no correlation. And there is a simple way by which I can calculate correlation, and that simple way is I say equal to OREL. OREL is correlation. Now I'm telling you, everything can be done in Excel. Just see, right? So we have array 1. Array 1, I'll just calculate array 1 as, I'll take array 1 as the number starting from the number of clicks, that is 13. Control shift down. I selected one part of my data. Now correlation is between two things, that there is two features involved, right? And the second feature is here. See, it's comma array 1, comma array 2. I have to put a comma, right? And the second thing I need to supply is the amount. So I click on the last value of the amount, Control Shift up, Shift 1 down. So both the size of the arrays are same, right? I want to see what is the relationship between the clicks and the amount, right? So I hit enter. I happen to get a number which is 0.8958201. Very difficult for me to read. So what I'll do is I'll convert it to percentage. Okay. So this is the relationship between the clicks and the amount spent. I'm just making it, writing it here so that you understand it better later. So it's clicks and amount are correlated to an extent of 90%. Okay, so this is just telling me that these two variables are 90% correlated, right? So you must have seen that love calculator on Facebook, right? That is, like you have one person, you put one name on one side, one name on one side, and then you keep saying, like all the names in the people, all the crushes that you'll take, you'll put your name and your crush name, and then you'll try to find how much is the love between you. So that can be, this correlation, this number which gives you how much is the positivity, how many times you have moved together. Okay, this is what is simple correlation number. Okay, but then like the correlation only gives you the direction of their relationship. Okay, it's not giving any information about if let's say if there are two variables, let's say clicks and the amount spent, you basically have declared that clicks and amount spent are 90% correlated. Very good that you have found. You are very happy. You're going and telling your UI, or you're going and telling your CTO or your management, the team of management, that boss, see, I know a very important fact from the data that I've analyzed, that every time the clicks are increasing, the amount spent is also increasing. So maybe we should work on improving the user interface of our website, okay, such that we can make people click more number of times. Okay, this is a simple suggestion that you would like to give. But then there is a person who is sitting there in front of the the web developer. He will ask you, okay, fine, there is no problem, even we would like to contribute to the company's revenue, but then can you give us an estimate of, okay, if there are 10 more clicks that I do, okay, 10 more clicks that I do, 10 more clicks that I do as compared to current average, okay, as compared to current average, can you tell us how much will be the amount spent? Okay, so this is where your predictive analytics come into the picture. So I have clicks here, I have amount here. Okay, so I just take the current number of average number of clicks, there are 24. So he is telling you confidently there are 24 clicks happening on the website on an average currently. He is saying from this 24 I'll make it 34, 10 more clicks. But he is telling when there was a 24, okay, on an average I was getting a revenue of somewhere around like this much. On an average, I was getting a revenue somewhere around this much. But then if I make it 34, can you tell me how much will be the revenue generated? Now here is where we cannot use correlation. Correlation only tells us relationship between the two variables. I'll give you one more example with respect to correlation. Let's say we have, the degrees of temperature increase, okay, and let's say we have the sales of ice cream, okay. Let's say every degree increase in temperature, okay, the sales of ice cream increase by 100 units. Assume this is just a small example, okay, and I want to see if there is any relationship between the two. Definitely there is a relationship, because every degree increase the sales of the ice cream. So if I calculate correlation here equal to correl, it will be 100% correlation. See, comma, so 100% correlation, okay. At the same time, if the degrees increase, okay, and the sales of ACs, okay, I want to see the sales of ACs, sales of ACs. Then let's say, like the 23, 21, let's say 22, 23, 24, 25, 26, okay. So here every increase was increasing the sales by 100, okay. Here every increase is increasing the sale by 1, okay. See, like for example, equal to, let's say, correl. Here also the correlation will be 100%. You see, so correlation is not helping me to understand the impact. It cannot give me like every increase how much will be the increase in the sales, okay. So the simple concept that we can use over here is something called regression, okay. Here is where your predictive analytics comes into the picture, okay. Let me just make a note of this step. Step number 5, predictive analytics. Okay, this is a very simple predictive analytics using univariate linear regression, okay. Univariate linear regression. So what is the relation, what is the difference between the correlation and the regression is correlation only help us understand the direction of relationship. It doesn't talk anything about the impact, okay. But then our something called regression help us understand the impact, okay. It tells us how much will, or it has a power to predict basically, okay. So now I'll just take this up, okay, and I'll put it down so that this comes under the predictive analysis. And I want to understand if there are 34 clicks happening on the website, how much will be the amount spent, okay. First of all, let us try to visualize this relationship. Now how do we visualize the relationship is, okay, there is something called as a scatter diagram that I can use, okay. So I select this data, both the data I've selected together, the clicks and the amount spent. I go to insert. In insert, you will find something called scatter graph. See, I have a scatter graph, and the scatter graph will appear here. Okay, let us analyze the scatter graph. Okay, let me just get it down. All right, so we have a scatter graph here. This scatter graph is having on x-axis the number of clicks and the y-axis the amount. Okay, always you should keep there is something called as a dependent variable and an independent variable here. Independent variable is the one which is like on which the dependent variable is dependent on, that is your amount spent will be dependent on. See, it's like there is a concept of something called correlation and causation. It's like just to explain it in a very simple way. You see, we said that when the temperature increases, the sales of ice creams will increase, but then it's not the other way around, right? Is it like we are eating more ice cream so temperature outside is increasing? No, it cannot happen, right? So it's only one way, okay, where there is a cause and effect, okay. So no, most of the time the cause is the x-axis or independent variable, okay, that is the clicks, okay, and the effect, that is the amount in our case, is on y-axis. So the independent variable will also always come on the x-axis, and the dependent variable will always come on the y-axis. Okay, so this you will get a better clarity when you use, when you solve more number of use cases, and then you understand what you want to predict. So in this case, we want to predict the amount, so amount is on y-axis. Now, do you see this points are moving together? Let's see. Okay, these points are moving together. Of course, there are some points which are, which are kind of away from most of the points. Okay, these points can be referred to as outliers. I'm not discussing about them right now because it's again a big concept. So right now I'll just say I want to understand the trend in which these points are moving. Okay, what I'll do is I right click on any of these points and then I click on add trend line. Okay, and once I click on add trend line, I say, by default there is linear regression which is selected, and then I can say display equation on the chart. Okay, display equation on the chart. So this is the equation that I have with respect to chart, and this equation I'm sure everybody have studied in your school time. That we were under, there was a lesson by name the lines. Okay, there was a chapter by name lines, and then any line can be represented by using an equation called y is equal to mx plus c. Okay, so y is equal to mx plus c, plus or minus c. This c is nothing but if I extend this line where it will go and touch my y-axis, it will go and touch my y-axis at minus 1582. Okay, so that is a point. It is called as a y-intercept. Okay, and this m value is the slope of this line. This is the slope of this line that we used to calculate. There was a formula called y2 minus y1 divided by x2 minus x1, where I choose any 2 points on the line and then find this number. Okay, I'm not going into the details of this again. So this is the slope of the line, and x is any value of clicks. Okay, so for any value of clicks, I can find the value of amount by using this particular equation. So I'll use the same equation here. I'll say is equal to, okay, so y is equal to, that is y is amount, is equal to 353.62 multiplied by x is 34, okay, minus 1582.4. If I do this, it is telling me that, see, if you make it 34, the total increase in the amount, the effective average increase in the amount is 10,440, which is, if you want to see how much will be the growth in the amount spent, then you can say equal to the difference between the two, that is this, the new difference, the new minus the old, divided by the base, what was it before. So there is a 52% increase in the amount spent if you increase the number of clicks. And increasing the number of clicks is in our hand, but the amount spent is not in our hand. But we found there is a relationship between the clicks and the amount spent. Okay, guys, this is a very, very simplest example which I've taken to help you understand what a machine learning can do. And univariate linear regression is the simplest machine learning technique. Okay, it's one of the very beginning one and very, the simplest one. Okay, linear regression technique, where you can use this kind of techniques to predict and help businesses understand what they should do.